Oh, I'm counting in.
I really hope that all of you saw what Hadi just did. In case you didn't, I sure hope we'll include in the recording. Welcome to another episode of Talking Kotlin. Today I'm really excited because we're gonna sit down with Colin White, who's an Android engineer at Cash App and who's also the author of Coil. We're gonna spend the next half hour or so exploring what Coil is all about. And I think it's going to be quite exciting. But as usual, I'm of course also joined by my lovely co-host Hadi. Hadi, how are you doing?
I am good. How are you, Sebastian?
I am great. It feels weird that you say that with my full name. I'm used to you calling me Seb.
I'm sorry, Sebastian. I'm terribly excited to be here with you, Sebastian. Yeah. So what have you been up to lately, then, Sebastian?
Oh, I actually just.
How much am I going to annoy you with the whole Sebastian thing? Should I stop?
I mean, it's fine. There's a couple of nicknames I'm not super happy for you to use, but I'm not gonna tell
Sebi?
you. I'm not gonna.
Do you like Sebi?
No, yeah, it's great.
Oh, shit.
I mean, it's literally my Twitter handle.
It is
my ex Twitter handle. You know, I just actually came back from DroidCon New York City, where we talked a little bit about Compose Multiplatform, which was a really exciting time. Yeah.
Nice.
What's new with you?
Nice. But I just came back from the kitchen where I tried to talk about Compose Multiplatform, but no one was interested.
Well, I feel like,
to be fair, it was only the dogs there, and they're like, "Does this involve giving us a bone?" I'm like, "No." So yeah, they weren't really interested.
You could have incentivized them.
I could have. And talking about incentivizing, what do you? No, wait.
Yeah.
What do you normally incentivize? Okay, what is a good incentive? Oh, sorry. What is an incentive that is used for people?
Money.
Money. Talking about money, Colin from Cash App. Do you see? Whoa! I nailed it this time. Now you can't say that wasn't a good. What was it? Segue.
Yeah.
Yeah. There you go.
Very good.
That was definitely a killer segue. Yeah, thank you so much for having me on the show. Yeah, stoked to be here.
I have the feeling that as time goes on, our intros get more and more chaotic. You know, I try to do this thing where we catch people in the first couple of minutes so that they stick around. But I feel like at this point, you're ride or die. You're either in for the whole podcast or you're just like, oh, it's these folks again.
It's not about the numbers, it's about the quality over quantity. So a shout out to all those folks that have stayed here because we love you. And to the ones that left, well. So Colin, tell us a little bit about yourself.
Yeah. So I'm an Android engineer at Cash App, and I'm also the main author of Coil, which is, I think, the topic of today's show. And for folks who don't know, Coil is an image loading library for Android, but soon Compose Multiplatform. It basically provides a simple API for kind of fetching and decoding images from pretty much any data source. So it just kind of simplifies the whole process of you have like a URL and you just want an image, and it kind of handles that whole process for you. But stoked to be on the podcast.
And so Coil is spelled COIL, not KOIL, people.
Yep.
What does that like? How is Coil the name related to image loading?
Yeah, that's a great question. It's definitely the K was a point of contention as well. I got a lot of comments when I initially released the library. But Coil stands for Coroutine Image Loader. That's kind of the idea behind the name. It also is like a nice, short, punchy name, you know?
Okay.
That makes sense. So the core, I guess that means the core of Coil is all built on top of coroutines then?
Exactly, yeah. So Coil is really built from the foundation up on top of coroutines, on top of Kotlin. It definitely couldn't exist without those two things. And it's also very opinionated, right? Because a lot of times you'll have libraries that kind of integrate with coroutines and provide like extension libraries and things. But Coil is really built from the ground up to be Kotlin first, built on top of coroutines. And it it integrates with those as closely as possible.
You mentioned coroutines, built up from the ground up coroutines, image library. Like why? Why is the need for this? And doesn't the Android platform provide anything itself?
Yeah, so I think you definitely could go with like a thread solution. But when I was initially building Coil, I really wanted to be opinionated. I like the fact as well that coroutines, of course, kind of has a built-in shared thread pool. So I used to be very focused on like performance. So when I was initially designing Coil, I really liked, for instance, how the fact that OKIO shares buffers between so it's much faster to copy data, or it's much faster to just change ownership of like a buffer versus copying data. And coroutines, of course, has its own thread pool, which was really nice. And then I also just wanted to avoid all the indirection that would be required if I was to use threads, and then building with coroutines on top. And then also, of course, now that Coil is going multi-platform, we couldn't really rely on threads if we wanted to. We really have to use coroutines to support multi-platform, and it makes it significantly easier.
Gotcha. So for me, I think I would be interested also in maybe kind of a history of like maybe image loading and kind of what came before you decided to build Coil. Because I'd venture that ever since Android like 1.0, someone probably had to display an image from the network. At least on the surface level, it doesn't seem like a particularly hard problem. It's like fetch like some binary data from the web, and then just, I guess, display it. But I feel like there's probably a lot more to it once you start diving deeper into it.
Yeah, so kind of definitely, yeah. Since Android 1.0, since time eternal, man has needed or person has needed to load an image inside an Android app. So there are some heavy hitters like Glide and Picasso, and I believe Fresco as well by Facebook. And these libraries really simplified, the whole process of loading an image. So, and those libraries existed when I started out Coil in 2019. But I really felt that there was an opportunity for kind of a more modern image loader. Picasso and Glide kind of approach image loading from two very different sections. So Glide has like a bigger feature set. It's very extensible, whereas Picasso really is kind of built around a small binary size. And I wanted to, when I started building Coil, I wanted to kind of take elements from both. And I figured the best way to do that would be to take features from both. So I really wanted to leverage OKIO, OKHTTP. You can really, using those two libraries, offload a lot of work to support things like buffering data into memory, all the networking, all the disk caching, things that Glide has like separate classes for, that we could just offload all that work onto those libraries and make kind of the main Coil library just around taking in some data and decoding an image. And then really as well, this was around the time I started Coil, was around the time that Google announced Android was Kotlin first. And they started releasing all these KTX libraries as well. And so I really wanted a library that was opinionated about being Kotlin first. One of the things that Glide has as well is it has like an annotation processor. But really, you don't need that for an image loading library. You can just use Kotlin extension functions. And it's, of course, compile time way faster, no annotation processor. It's great. And then, of course, also, could replace threading with coroutines, which is just I think the big jump for me was coroutines is really like a language feature. It's not a third-party library. So it's very clear to me that like if you're going with Kotlin, you should go with coroutines. And I think the Google KTX libraries kind of cemented that as well, as they also sometimes import coroutines alongside the standard library.
So I think you kind of mentioned a couple of parts like caching and these kind of parts, but I'm wondering where does the initial complexity come from when it comes to just like loading images? Like what needs to actually happen? What do I need to do to get my image displayed properly and with good performance?
Yeah, so there's a lot that happens behind the scenes. Kind of the initial idea, or one of the initial APIs I wanted to support in Coil was just having like an extension method for image view that loads an image. So you call like imageview.load URL. And so when you do that, it then has to pass it through a bunch of layers. So first we have to like check, is that URL already in the memory cache? And if it is it big enough? If you are requesting an image at a larger size, is the image in the memory cache going to satisfy that requested size? Then when you kind of get past the memory cache, which is the quick check, you then jump to a background thread. So you need something to move off the main thread, which is where coroutines comes in. And then you have to look at what kind of piece of data this is. So is it a URL? So we're going to go to the network. Is it a file path? So we're going to load it from a file. Is it an asset? Maybe like on Android, a packaged asset. So you need to route that to the right fetcher. And then there's, of course, a ton of complexity with how Android loads all those different things on different API levels. So you have to figure out that part. But the most common, of course, is the networking. So when you get to the network loader, you then want to figure out, okay, is this already in the disk cache? And there's so much complexity around disk caching as well, and maintaining a persistent cache of files. But yeah, you check the disk cache. Is it there? Yes, no. There's a lot of threading and synchronization there as well, to make sure that the file will stay there in the disk cache while you're also decoding it. Because then once you've found the image, you've either loaded it from the network or the disk cache, then you have to move to the decoder. And there's a whole bunch of options there. On Android, we use Bitmap Factory Decoder, but soon for multi-platform, we'll default to Skiko, which we can probably talk about later as well, which is a great Kotlin multi-platform library that lets us use Skia to decode images. Then you load it at the required size. You don't want to load it too big because you don't want to take up too much memory. You also don't want to load it too small as well, or it'll be noticeably a bad looking image. And then finally, you jump back to the main thread and you give that image to the UI, and it's rendered.
Okay, I think I understand now why there's a need for a library here. Because again, like when you think about it from a super basic level, it feels like it should just be making a request and then displaying it. But obviously, there's so many more things. I do wonder. So one of the things you did mention was that, for example, Coil also can differentiate between different image sizes. So does that take into account the screen density, for example, in that case then?
That's a great question. So it takes into account the requested size, which also takes into account Coil typically works with just raw pixels. So it'll check, is this image view 100 by 100 pixels? It doesn't deal with density too directly, but it has custom size handlers for image view, for view generally. And then, of course, for composable, there's a great way we use to grab the size of a composable. There are actually multiple different ways depending on if you're using the async image API, which is a composable, versus the remember async image painter, which just provides a painter directly that you can then do what you want with it. And so there are a number of ways we kind of figure out the size the image should be.
So is the size of the image, is that mainly a matter of like caching in that scenario, or is this also a matter of actual like display performance? Like is my app gonna be smoother if my images are smaller because they don't have to be resized on each composition, or how does that work?
So it does. If your images are smaller, that definitely helps because it means less work has to be done on the back end to kind of resize those images. But Coil really tries to make it easy. So if say you have a 4,000 by 4,000 image, this big image that you're loading and that you want to display, but you really only need to display it at like 200 by 200 pixels inside the actual screen. Coil will handle that whole process of downsampling the image So you're only storing a 200 by 200x pixel image in memory. Otherwise, I think even, if you load something just over 4000 by 4000 on Android, I think it might actually just say no. I think there is a max size that you can even, it'll just be like, nope, that's not going to happen. So Coil gets around that by handling the whole downsampling process for you.
That's pretty cool. And so how did people do this before Coil or equivalent libraries? Was this all a manual process?
So definitely for some libraries it is. I think Glide also handles this process a little bit differently. And of course, Glide is Android only. But you used to have to declare the size yourself, whereas Coil will automatically figure out the right size for what you're looking to display in Compose, in Views, wherever.
So it sounds like really going without a library is working on like hard mode in this scenario.
For sure, yeah. It opens you up to a lot of complexity, which ideally you don't need to handle. I think, loading an image from the network from wherever is really something that everyone needs to do, which is why you just want to simplify your life and then import a library, hopefully Coil.
Okay, so I have to ask a question. You do your work on Cash App, which generally I assume is somehow related to the concept of cash.
That is correct. We
Okay,
do
good,
handle money.
The money version or the in-memory cache version that we've been talking about. Anyway,
bit of column A, bit of column B.
So, why did you start working on this? I don't see that Cash App is a very image processing intensive app.
Definitely. So I actually started working on this at my previous employer before I started working at Cash back in 2019. And I started working on it in my spare time. And my previous employer was Instacart, which is a grocery delivery company.
Yeah, that makes sense now.
Yeah, so they have a ton of images and it's a very image heavy app, the client app, as well as they have multiple apps, and it's all image heavy. So I was really working with a lot of Glide specifically, but a lot of loading images. And I really felt that there was a place for Instacart. Was also very early on Kotlin. They started working with it pre 1.0, so I was really loving the language. And I wanted to, build something that was opinionated about the fact that the feature set that was available, the fact that I felt we could make a similar library to Glide with a smaller binary size, and the fact that I wanted to use things like coroutines. I wanted to use Kotlin itself. I also wanted to build directly on top of OKHTTP and OKIO. And then I wanted to support Android lifecycles as well, which is something the other image loading libraries weren't doing. They weren't supporting the lifecycle component.
So did you build Coil with the intent of making it a public library, or did you start it out as just let's see if we can make our own lives easier, and if it works out, we'll also publish it?
So I started building it in my free time. It was I was at Instacart, but it definitely wasn't something that I was spending a ton of time at Instacart working on. And it was always intended to be a public library. I had chatted with some of my colleagues who really pushed me to make it a public library. And that's why it actually got released as like a 0.50, I think, as opposed to a 1.0. But it was always intended to be a public library. And
Very cool. So do you know of any I see that it's a very successful project, right? You have about 10,000 stars on GitHub. Are you aware of any large apps out there that also build on top of Coil?
Yeah. So the community response to Coil has been pretty amazing. It's been pretty awesome. Especially working with other folks in the community who've offered excellent feedback on things, as well as on the Compose team themselves. They really helped out with a lot of things around performance and things like that. So it's been very awesome. In terms of libraries that import Coil, there's a bunch. I don't think I even know the full extent of libraries that import it, but a few of my favorites are Slack uses it. They, of course, also do awesome multi-platform stuff with their library Circuit. I recently found out the ChatGPT app on Android imports Coil. Uber imports Coil, my previous employer Instacart as well. And then I think the Google Play Store actually imports Coil as well. I'm not sure exactly where it's used, but I think if you decompile the app, you might find some Coil references in there. And then, of course, many of Google's Compose samples import Coil as well.
It's the point where you're like, well, maybe I should have charged a license fee.
Let's
not go there.
Open source.
Let's not go there. So you said that a lot of people give feedback. I'm pretty sure they do. A lot of people give feedback on open source projects. Do you have any active contributors as well, or is it mostly just yourself?
I'd say it's mostly me. There are a few other folks as well who have shipped stuff for the library. So there's a few folks on. I think there's folks are on. There are other few folks I work with, but I think most of the feedback has kind of been through like direct messages, through on Slack, and other folks. But I'd say it's mostly me kind of working on it.
And you, just to remind me, you live in Nebraska?
Yeah, I live in close enough. I live in Seattle, Washington.
That's the reference to that XKCD, right?
Yes. Oh God, you don't. If I have to bloody explain a joke, Seb, it's no longer a joke, is it?
Oh, yeah, I'm just making sure for myself and for the audience. That's
yes. All. Anyway, now on to more. Now this is the serious part of the. Lately, we've been having to have serious parts of this show because this is the part where I say you have won an award from the Kotlin Foundation on behalf of the Kotlin Foundation. We very much appreciate all of the work and the effort that you've put into this project. Congratulations. Now let's move on. So you got some money, right? From the Kotlin Foundation. Is this multi-platform?
Is it multi-platform? It's not multi-platform yet, but soon. So that was the main pitch to the Kotlin Foundation, and thank you again for the grant. The main pitch was to essentially make Coil multi-platform, because Coil's largest upvoted ticket on the issue tracker is multi-platform support, and it's been that way for a while. And I was initially a little resistant to kind of supporting multi-platform, if I'm honest. Just I felt the amount of work that was required to kind of pull out all the Android SDK references and make it just work nicely with the same API on multi-platform. Felt that was almost an insurmountable task. But I've since reconsidered that position. A lot of folks, like I mentioned, have reached out and given me ideas on how to better support multi-platform. One of those is using Skiko for decoding images. That lets us decode images using common code much easier versus if I had to build that myself. The plan for Coil 3.0 using this Kotlin Foundation grant is to same API as Coil, same thing that it's already doing at the moment, and just have it work with Compose multi-platform in a very easy way. I'm looking for as few API changes as possible, just direct support for Compose multi-platform, and that's the goal, and I think we'll achieve it fairly soon. I don't want to commit to a hard deadline, but
don't worry, we'll get it out of you. You said that I just want to clarify something before I give you way to you, Seb. You said that I've recently reconsidered it. I just want to clarify to folks listening that no, it wasn't that much money that we threw at you that made you reconsider this. I'm assuming that reconsideration was for other purposes or other motivations.
Absolutely. It's definitely a technical reconsideration around the implementation details.
So I think it's always very interesting to look at libraries that are established in the Android world and seeing them transition to a multi-platform future, just because it's something that actually a lot of libraries go through that a bunch of the official Google libraries from the Jetpack kind of suite go through right now. So I'm curious. I saw on GitHub that work on this has definitely already commenced and things are moving around. So I'm curious, kind of where you see the main challenges, or where the main brunt of the work is going to go as you make this transition.
Yeah, definitely. I think the main challenge that I'm still working through at the moment is getting rid of all the context references, especially with graphics and kind of dealing with anything in the UI on Android. Context references are all over the place. So removing those, putting them at an arm's length behind an interface or something else. I think Coil 2.0 already does a decent job of this today, but it's definitely not completely there in a way that we could just jump to multi-platform easily. But things already exist inside Coil, like the size resolver interface, which abstracts away a reference to a view and computing the size required for an image behind an interface that's already common code, basically. And yeah, so making sure we pull out all those context references. I was a little worried about pulling out the bitmap factory reference on Android as well, but fortunately, Skiko makes that much easier again to just kind of provide it an input stream and have it decode the image for us and in multi-platform. So those are kind of the two main things. And then, of course, networking. Unfortunately, OKHTTP isn't a multi-platform library yet. Maybe I don't know, but need to figure out networking. So that likely means importing Ktor, something else like that. Though I do think for Coil 3.0, it's likely that the networking piece will be pulled into a separate artifact as well. So folks that don't need the networking, don't need like a Ktor dependency, they can choose not to import that if they want.
Can you actually bring in your own like HTTP client? Does Coil provide these abstractions for you?
For sure. So it actually sits kind of a level above like an HTTP client. Well, I guess if you import Ktor, then you can provide your own HTTP client yourself if you want. Ktor exposes that, right? But you can also provide your own custom fetchers, which essentially turn a piece of data into any OKIO source. So you can, wherever you're fetching the data from, be it networking, disk, anywhere else where you want to get your data from, you can plug in your own fetcher.
So you said already that you currently depend on OKHTTP, and that'll have to be replaced with a multi-platform thing. Is there actually any other like third-party libraries, maybe that as you looked into this transition, you found out, oh wow, they are already multi-platform, or getting rid of them was easier than you expected it to be?
So definitely, I already knew it, but OKIO, of course, is multi-platform. Was really stoked to see that. I think OKIO is probably my favorite library in terms of just how easy it is to use, how fast, and the fact it works on multi-platform. So Coil 3.0 will still use OKIO as a base for any IO. There's, of course, the file system API that it has that makes it very easy to support disk caching on different platforms, which would be another thing that would be very tough to write ourselves. So OKIO, and then I think, Coil 3.0 largely just depend on OKIO, the standard library, and coroutines, and trying to keep the dependencies very minimal.
So I saw something on the GitHub page of the library that said it's very lightweight. It only has 2,000 methods.
Mm-hmm.
Is that still a thing in the Android world? Like, didn't they solve that problem?
They did solve it a while ago. Fortunately, I think it was the 52K limit or something. That's fortunately gone with multi-dex, and I don't think anyone supports below Lollipop. I should probably update that. It's probably slightly more than 2,000 at this point as well. But overall, keeping Coil lightweight is a priority, and I think Android developers still identify with counting the number of methods. It's like a relic from the past, even though it's not necessarily the hard requirement that it used to be that you needed to sit under that limit.
So let me
daily ritual. the
let
daily
me-
ritual. Okay, go ahead.
No, sorry. Go ahead. Just go ahead. Go ahead.
No,
Go ahead.
I just wanted to say, is it like the daily ritual of an Android developer to look at the APK and then like count and
count the
just,
methods.
like, do a couple of graphs? Yeah.
Absolutely. I think should count the number cache has.
Yeah, I was just going to say that the beauty, like, I can understand. I didn't want to spoil your marketing tactic, right? Just drop the 2000, leave the word lightweight in there. It'll sell enough. Like, it doesn't matter, because that's the beauty of the word lightweight. Everyone interprets it differently, right? But as long as it's got the word lightweight on there, it's all good. And this segment of marketing has been brought to us by our plank of wood.
There we go.
That's a
That's a
great
sponsor
point.
I can get behind.
What, a plank of wood?
Yeah, that's a solid foundation to build upon.
Do you know what I use that plank of wood for?
Do I want to know? That
Oh,
sounds
you
ominous.
bloody well do. So I did the other day when my kid comes to me, he's like, "What's this?" I said, "It's." No.
Don't, Hadi.
What's this was a watch. It was the old-fashioned watch, not these ones that you have to charge every night, right? So he's like, "Oh, can I have it?" I'm like, "Sure." I tried to change the battery, it works. Tried to put the case back on, bloody thing wouldn't go on. I had to put the plank of wood and stand on it until it clicked back in. So that's what I use the plank of
Wow.
wood for.
Is it waterproof, the watch?
It was.
Yeah.
It's
I
not
feel like
anymore.
I feel like it's fused shut now.
Yeah, no, it's not anymore. But anyway, so going back onto the marketing aspect. So yeah, so it's still lightweight. Yeah, you need to get rid of that thing, but otherwise, but no, really, seriously, it's like you've got a lot of adoption, and it's great. So, in addition to the whole Compose multi-platform stuff, what else is in the works for you and Coil?
Yeah.
Coil.
So Coil. So definitely
just-
the.
Yeah, I was just
Sorry,
going to say, like, it's Colin, Coil, Collie. I just feel like there was an opportunity there as well,
It's in my Twitter bio as well. That says I swear I didn't name the library after myself. I swear I promise. Yeah, so definitely Compose multi-platform is the first and main priority. So adding support for that is top of mind. But there's a number of other things I really want to support as well in Coil 3.0, including network request pooling. So at the moment, if you have multiple requests that come in for the same URL, it'll fire off 2 separate network requests. But I really want to support pooling network requests, so it just fires off 1 request. And then I also want to support caching animated images. There's some complexities around that I won't dive too deep into, but supporting that I think is something that's feasible, but a little bit more work. So those 2 things are second of mind.
I'm very sorry because I might kick you down a rabbit hole here, but I'm very you'll have to elaborate a little bit on the animated images for me. Just
Sure.
Because again, in my mind, it's a matter of I take my GIF or PNG or however you want to pronounce it, and I load it onto my disk, and then it's there and I can play it. But it sounds again like there's much more complexity that I'm missing here.
Oh, yeah. So I'm talking about Coil already disk caches all that stuff. I'm talking about memory caching. Making it so if you load in a GIF, it can put it in the memory cache. And the main difference is when you're loading a static image from the memory cache, we can keep that image in the memory cache. There's kind of nothing moving around, so we can read that memory cached image multiple times. There's no kind of mostly there's no mutable state that we need to worry about. So we can just share that image across multiple UI pieces, composables, image views. It's a little tougher with animated images because we need to take that thing from the memory cache, and it can only be used by one image view or composable at a time. And then when it's done with it, we have to put it back in the memory cache, and then we can take it away again next time. So if you think you're like scrolling, if you scroll down a list and a composable goes off screen, we want to put that back in the memory cache. And if you scroll back up, we want it to take it back up the memory cache. So that's the goal.
I have a couple of other questions that maybe are a little bit opposed to the lightweightness, but I actually did see that you have a bunch of extra features, I guess, that are already supported, like video loading, for example, but also support for SVGs, which I believe are notoriously not supported out of the box on Android because they kind of went the XML route for vector graphics. Is that just is here the approach just to go through like separate like modules or packages that you include only if you need them?
Exactly, yeah. So Coilbase is kind of the main artifact that sits all the way at the bottom of the tree, or all the way at the top of the tree, and that is meant to be as lightweight as possible, as few dependencies as possible. Like so, I mentioned for 3.0, it'll only depend on OKIO, standard library, and coroutines, and then you can pull in other dependencies that include implementations of decoders and fetchers for specific for specific pieces of media that you want. So yeah, we support SVGs, GIFs is a big one as well, and then video frames as well. And then hopefully, I would love to be able to support MP4s in a nice, easy way in the future as well. There's some complexities as well that prevent that, but MP4s are basically just better GIFs at this point.
So it really is. I'm so glad we're moving away from GIFs. I'm a little surprised that animated PNGs never really made an impact, but it is what it is. Yeah. So one of the things that I was also curious about, just from a personal perspective, because I'm tinkering on a couple of side projects, and I wanted to show like blurred preview images that are included with my regular JSON payload before I actually load like a proper image. There's a couple of different implementations for this. There's Blur Hash from Wolt, the delivery company. There's Thumb Hash from Evan Wallace, the guy behind ES Build. So I'm curious, do those also slot in somewhere with Coil?
Yeah, so you can set a placeholder for an image in Coil while it's being loaded, fetched from the network, whatever's happening on the background thread. In terms of a blurred image, it might be a little tougher. I'm just thinking of because unless you're doing that blurring ahead of time, or if you're doing on the main thread, which I'd probably avoid, then yeah, passing that image. Coil doesn't currently support like asynchronous placeholders and chaining requests and that, since that adds a lot of complexity. But you could definitely, if it's a quick blur, then you could maybe just blur it ahead of time and then set it as the placeholder for the image.
So the idea with a lot of these libraries, at least, so I personally looked more into Thumbhash, but I think Blurhash has the very same idea. It's just that you have a very short string of maybe 64 characters, like literally ASCII characters, and then you just extrapolate those using a bunch of cosine transforms and other funky stuff that I don't understand to blow it up into an image that roughly represents what your big image is going to be. So I think the idea is that you can do that on the main thread rather quickly without going asynchronously, like as a pre-blurred image. You just need to blow it up.
Nice. Yeah, then you could probably just quickly generate that blurred image, drop it in as a placeholder, and you're good to go.
But there's support for placeholders, and then like what transitions between the placeholder and the real image, or?
Yeah, so Coil has support for a number of kind of niceties. So you can support transformations on Android, though I don't know if those will necessarily make it into the Compose multi-platform implementation. I think there are just better ways to do that kind of stuff with modifiers, for instance. So if you're doing any clipping, you're better off using a modifier versus a Coil transformation. But yeah, there are transitions as well. Coil comes built in with like a crossfade, since that's the main one almost everyone uses. But you could definitely write your own to do any sort of custom transition. Maybe you want to do a 360 when the image is loaded, but that's not in the box.
So where do people that aren't those 10,000 folks that already know about you go to learn more?
Yeah, so if you're interested in Coil, you can go to github.com/coilkt, coil-kt/coil. And then if you want to hear more from me, you can find me on Twitter or X. I don't know. Twitter or X Twitter at Colin WHI. And then you can also find me on Threads at Colin RT White.
And if you're in the
I'm
EU, you can't do that. So there you go.
Oh no, I forgot about that.
Yes. Well, good. Anyway, you said before, I just want to look back in here. You said before that I don't have any strict deadlines with the whole multi-platform. Just want to remind you that, you know,
Hardy has a plank.
Yes, he'll get me. Don't worry. I'm confident. I guess I can say I'm confident that it'll be before end of year.
Okay, that's acceptable. We'll check up
Very
on
good.
you.
Yeah. Well,
We'll check up on you.
Okay.
that's really exciting. I'm really excited to have another like very well adopted part of the Android world move into the multi-platform and specifically Compose multi-platform era. Because once again, everything that's multi-platform, when people adopt it for their own apps, they don't have to switch out that dependency. They can just kind of keep going. It makes their transitions easier. So that's delightful. Very cool.
And once again, Colin, thank you for joining us on this episode. And I know that it's very, very early in Seattle, so we'll allow you to, I'm going to say go back to bed, but probably no, get ready for work, right?
Right, exactly. Yeah. Thanks so much for having me on the podcast. This was a lot of fun. And thank you for the grant from the Kotlin Foundation as well.
Thank you so much for sharing all these behind the scenes. I am now much more worried about doing image loading manually, but I also know that there is a library out there that has my back.
Yeah, you got to take that sample Compose multi-platform app that you've been working on, the image loader. You got to switch it to oh no, wait, you can't switch it to Coil because it's not multi-platform. Colin,
We'll get there. We'll get
January, he's going to switch it over. He'll be your guinea pig.
Awesome.
Sounds
stuff.
good.
Okay.
Take care.
Thank you everybody for tuning in today. Hope you enjoyed this episode. And of course, if you did, you can feel free to leave any kind of comments or other social media interactions as you please. I genuinely don't know if there's still a bell on the YouTube UI.
I think there is because I saw the video that they just put it in there. But if you didn't enjoy it, obviously you can also do a thumbs down. But no one else is going to see it apart from us. We don't even look at that stuff. So save yourself a thumb. Save yourself a click. There you go. Save yourself a click.
And we will hopefully see you in one of the future episodes. Take care, everybody. Bye-bye.
Doop, 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 doop. Is that the outgoing music? Doop, 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 doop.